So here's where we start. We're going to draw a little line representing our westbound part of the travel, and then it turns
45-degree angle southwest.
So then we go 45 degrees southwest.
98 kilometers.
98 kilometers there. And what was the first stretch?
230.
230 kilometers. So let's make this shorter. Okay. So displacement, if we were just looking at this kind of visually, what we're looking at is their beginning point and their end point. We just want to know how much distance is in between those 2 points. So if we were talking, what distance did this car cover? Well, we'd say, well, it's just they did 230 kilometers here and they did 98 kilometers there. So they did 328 kilometers. But that's not what we're talking about. We want to know just the final point and the beginning point. How far away are those guys? So we're looking for...
As the crow flies, huh?
Yeah.
Straight point.
We're just looking for the shortest distance between those 2 points possible, so
Okay.
Straight line. And so the way that we are going to approach this is going to require a little bit more than just adding these two numbers together. That's probably what we want to do, because that's the simplest thing, but we can't do it quite that simply. So let's get this out of the way. So what we're going to do is first we're going to recognize that this arrow right here is on a diagonal. Whenever we see vectors or arrows on a diagonal, our first instinct should be to break it into components. And so when I say components, what I mean is break it into a horizontal piece and break it into a vertical piece.
Okay, so when you see a vector that's on an angle, you want to break it into a horizontal angle. So you want to break it into a y and an x.
Good. So an x component and a y component. So usually the question, if it's written correctly, is going to give us enough information that we can do that not only visually like this, but we can also start throwing some math in the question and do it mathematically. So they told us that this was a 45-degree angle. And they told us that this arrow right here was 98 kilometers long. So with those two pieces of information, we know enough about this triangle, and also knowing that we've just created a right triangle, so that's a 90-degree angle right there. With those three pieces of knowledge, we can now start using some trig functions to figure out what this length is right here of this x component and the length of this y component here. Any ideas how we...
Cosine.
Good. So if we do cosine of 45 degrees.
Which would multiply by 98.
Okay, good. Yeah, so it's adjacent over hypotenuse. So adjacent is going to be this guy. Let's go ahead and call that x, because that's our x component, over hypotenuse, 98 kilometers. And you were ahead of us because you said, well, instead of writing it like this, let's just multiply this over. So with some rearrangement, we get 98 times cosine of 45. That's going to give us our mystery length right there. And that's just something we can plug into our calculator.
And at first that's what we were thinking, so now we just add that to the 230, but now it's the actual vector that's coming from the first to the last point.
Right. So once we get this length...
Now, those are the terms that we kind of are misleading to us too. So it would be VI and VF, or what? For the resultant vector? For like a vector initial and vector final, or does that not relate to this problem at all?
Yeah, well, this isn't really a vector because it's just a distance.
That's direction too.
Yeah, I guess you could call it a vector.
We can address that at some other time, don't we?
Yeah, if we wanted to call this a vector, which I guess is appropriate, we could say this is vector 1. We could call this vector 2. And then so we are looking for vector 3, which is equal to vector 1 plus vector 2. If we wanted to think about it, if we wanted to use vector terminology and apply it to this question, it would be something along those lines.
Okay.
We would say we want this vector, we're adding it to this vector, and we want to know what that resulting vector it would be. And so this is how we would state that with a mathematical statement.
Okay.
Cool. So let's go ahead and plug that in. Or did you already do it?
69.3 is what I got.
So 69.3 kilometers. So now we've figured out this stretch, 69.3. And then because it's a 45-degree angle, we can go through and we can do the same thing using sine of 45 to solve for opposite over hypotenuse. But if we're quick on our feet, then we'll know that 45-degree angles is kind of that magic angle where,
So vertical.
yeah, these two sides are going to be equal to each other. So once we found that one, we just automatically know this is going to be the same, just for 45-degree angles. Cool. So now that we've got this hard to work with diagonal vector split up into two easy to work with vectors, all we need to do is recognize that this car, in reality, it's the trip that it took is the same thing as, it's the equivalent trip of just going 230 kilometers plus 69.3 kilometers west, and then going 69.3 kilometers straight south. So all we need to do is just make kind of a new triangle, just so it's not as messy, and we say, okay, we're starting here, we're going all the way west, and then straight south, and now we're looking.
Then you can redraw your angles and your total length, and so you have a 90 degree, and you have.
We actually don't need to know this angle or this angle. We could find it if we wanted to, but now that we know the length of this side and we know the length of this side, and we also know Pythagorean's theorem, which is a squared plus b squared equals c squared, we can find the length of the hypotenuse.
Nice.
So this would be 230 plus 69.3.
299.3.
Yeah, 299.3 by 69.3. So Pythagorean's theorem tells us that if we take the square root of 299.3 squared plus 69.3 squared, we'll get our hypotenuse.
Which is 307.2.
307.2
That's where he was
kilometers.
saying Pythagorean theorem.
Mm-hmm.
Yeah, that's where he was saying it.
Yeah, so someone else came in with this question, and their wrong approach was they were trying to do the Pythagorean theorem with this number and with this 98 number.
Yep, that's what we were doing.
And so it's a tempting option because it's like, oh, I've got a triangle, I know two of the sides, I'll use Pythagorean theorem to find
90 degrees.
the third side. But yeah, it only works with 90-degree angles. So it's a really cool trick and tool, but we have to be careful that we only use it appropriately.
It's so simple to show us the step of redrawing a larger triangle and then using it on the 90 degrees.
Except he tried to teach us where you know adding components and different crap like that.
Yeah, and that's what we did. I mean, we
Makes it
added
so
this
much
component and
easier.
that component to get a new x component. And then
But
we've
he was
got,
showing us how to add vectors.
Yeah.
He was showing
actually.
adding vectors.
Mhm.
Adding two vectors using the resultant vector and plugging that into the Pythagorean theorem. So, anyways.
cool.
But, yeah,
But that made sense?
Yeah, it made
This
sense.
approach? Good deal.
That made very much sense. Okay, and so then the second part of this question says, what is the displacement of the car from the point of origin? And then it has parentheses direction. So is that the
Oh.
angle from which they've...
Yep. So now they're looking for, we said the magnitude of this vector, but now it wants to know the direction of this new
Okay.
vector that we've just made, this dashed line.
Mhm.
And so if we keep in mind that, you know, this is our x-axis and this is our y-axis, the most intelligent way to report this direction is probably going to be to say something like, however many degrees this ends up being, we're going to say so many degrees below the x-axis. So you need not only a degree, but you also need a reference point. So you can't just say, oh, this vector points 33 degrees, because that makes no sense. You have to say it points 33 degrees, you know, above the x-axis or to the right of the y-axis or something like that. Does that make sense?
Mhm.
So how do we go about solving for that theta right there so that we can get our
We
degree?
have 90 degrees.
Yep, we know this is 90 degrees here. We know the length of this side of our triangle and this side
So you
and
do-
this side.
You do side.
You would do the inverse
sine and sine.
tangent of opposite over adjacent.
Good. Yeah, we can actually do the inverse of any of our trig functions since we know all three sides.
Mhm.
So we could use inverse sine, inverse cosine, or inverse tangent.
Oh, that's right, we know hypotenuse too, so.
Yep, because that's just that value right there.
So,
But yeah, since you said tangent, let's go ahead and do that way. So we know that tangent of our mystery angle, theta, is equal to opposite over adjacent. We want to get theta by itself because that's the variable that we're looking for. So we rearrange it and we find out that theta is equal to inverse tangent of this fraction.
So,
Cool. And so it does say you always want to look at the description that it gives. So in this case it says south of west, which is what we found.
yeah.
If it had said something like west of south, then we would
Especially
have...
on the test, it might say the exact same answer, but it's saying, yeah.
Yeah, but then we would have said, okay, here's our south axis. We want to find this angle now, which is easy to do unless we just overlook it and then we end up giving this angle instead of giving this angle because we weren't careful. But in this case, the way that we solved it was the way that they wanted us to solve it, so we're good.
awesome.
Any other questions with that?
Southwest.
Was it just a two-part question
Yeah.
for that
Yeah.
setup?